Welcome to the video talk through for From Social Science to Data Science by me, Bernie Hogan. And this is Chapter 8 on research questions. So research questions are a bit of a departure from a lot of what we've done before. There's not really going to be any code in this chapter. It's more going to be a chapter about reasoning and about reasoning about scientific claims. This is something that we would normally do with some statistics, and of course the statistics and statistical logic is going to figure into this. But it's something that I think is worth covering right now because, well, we have some tools, we have some things available, we can go out into the web and get stuff. But how much stuff? When do we get the right stuff? How do we compare things? And how do we ask questions about it so that we can make a meaningful claim? So we're going to try to cover that today and sort of structure that into some learning goals. First, we're going to focus on that in terms of what is a research question and how is it used to motivate research. Second, we're going to consider inductive, deductive, and abductive reasoning as applied to a research question. We're going to want to be able to distinguish between prediction and explanation as separate but useful approaches. And finally, we're going to want to articulate how operationalization is constraining in order to make claims. Well, no, this is finally. And then consider how boundaries around distributions are a key way in order to make claims through comparisons. Okay, so first let's start off with, what is a research question? Well, research helps us make the world more knowable, even if doing so changes that world. We don't want to make an assumption that someday that's the end. We've finished all the research and we know it. Even the act of learning about the world changes the world, and as we apply it to the world, of course, it's gonna change in some way. This is especially the case on social media, which itself seems to adapt both on and between platforms as we learn about how people behave on social media and either integrate that into code or integrate that into legislation to maybe steer that code. But so, nevertheless, we do think that the world is knowable to some extent and that we should know more about it. But there's a lot of world out there. And so we want to find a way to focus our inquiry on the world so that we can extend what is known. So we can some would say, stand on the shoulders of giants. So a research question is therefore, it's a focusing device. It's a means for motivating a specific inquiry into the world. Okay, great, but what motivates a research question? Well, we might say a research question itself is motivated by prior literature, by personal experience, and by opportunities to collect data. Now, there's lots of other things that can motivate a research question. The history of many different papers can be quite circumstantial, but these three tend to make a lot of sense. Generally, in a paper, you're going to express your motivations for a particular research question primarily in terms of prior literature, things that other people have said or that other people have done, and you may also include some personal experience or reasons why you believe, either implicitly or explicitly, that you can apply this sort of literature to understand a different phenomenon or the phenomenon in your paper. So it's a misunderstanding to think that we have a research question per paper, or that the research question itself is fixed. In fact, the research question tends to go through a bit of a metamorphosis as the research goes on. Because at first, it's something that you hold while you're thinking about how to put the research together, how to design the study, how far to take the data collection, and so forth. It helps you decide or help arbitrate between different possible strategies and go, well, because of the research question, we should go in this way. But as the work evolves, you may learn certain insights about the work, or may be able to communicate exactly what it is you're doing in a slightly different manner. So the research question, that metamorphosis, becomes the research question for the reader. When it's the research question for the reader, it's very often done kind of amidst or just after some prior literature. What you're doing is you're describing a context out there and then saying, well, there's something we don't know, or something that's worth considering. And then you kind of summarize it for the reader in terms of that research question. So when you read papers with research questions in it, they often kind of take that character. But that doesn't necessarily mean that that's what the research question is going to be for you right away. Often your research question is going to be maybe a little more vague and is meant to just focus. And if you're too specific, it might not you might not be able to focus on that. And if you're too vague, it might not be able to help you focus. So working through a research question, you'll know you get it right when it gives you a sense of motivation or purpose, and that, like, yes, I want to go and investigate this particular topic. So I say investigate, and I'm kind of cautious with my words here. And one of the ones I don't use here, we're going to go prove that topic. Now, generally speaking, we would tend to know that in science we don't think of ourselves as proving things, but as failing to disprove. And so that's kind of an interesting approach from Karl Popper and from the what we might call the hypothetico-deductive method. But the thing is that it's that method might be a bit restrictive, and I'd like to offer something a little more general than that, and that is that the scientific approach to knowledge is one that oscillates between expectations and observations. So within that context, a research question asks about a relationship or a context where we can observe potential relationships. So let me rephrase that again. A research question asks about a relationship, or it can ask about a context where we can observe potential relationships. That is to say, we don't want to presuppose that there's a relationship either between some data and some particular type of sample or user, but if we go out and observe, we assume that, well, we might find that relationship and that would be interesting. Now, that said, hypothesis is related, and you'll often hear people talk about both hypotheses and research questions. Your work does not need either of these. It can often benefit from both, but it doesn't need them. A hypothesis is what we would use when we want to posit a relationship that could be falsifiable. Now, oftentimes, that criteria is too strict. And so for that reason, a research question can be a really useful sort of device to help us focus the inquiry without going through the sort of the rigid methodology of a hypothesis. Now, just to note here, when I'm talking about a relationship in this sense, we're talking about a relationship between a distribution of measurements. Now, when we observe one measurement, let's say, does that help us improve our knowledge of the other measurement? If we know something about one thing, does that help us know something about something else? If it does, we would say they're related. That's not to say one causes the other thing. We tend not to focus on one thing causing something else. And thus, within that, we're not really focusing on proving a thing, but rather we assume that there's some relationship out there. We go look to see, can we find it? Does it exist? And if it does, well, then we'd say we failed to disprove the presence of that relationship. Not that we've proven it, but that we failed to disprove the absence of this. We say, well, we're not sure exactly what it is, but we're pretty sure there's something. And so now that's, of course, partially because of the absence of, well, total knowledge. We cannot fully know all of the circumstances that led to any particular event or relationship between two variables. And so in that sense, we would want to, not make an assumption that we are absolutely proving something else. So now the way we would do that is often through lines of reasoning, which we would describe as inductive, deductive, and abductive. Abductive is, I don't know, maybe the cooler third one that you don't hear so much about, but I tend to like abductive reasoning, and we're going to hear a bit more about that as we go along. So we use reasoning just generally to make sense of observations in the world. Now, inductive reasoning is reasoning from observations to theories. We would do this when we classify data and build up theories from shared features. Now, deductive reasoning is reasoning from theories to observations. It's in the other direction. We do this with experimental data when we posit the influence of some stimulus. Now, why would that be the case? Because we're setting up an experiment is to say we have a theory that X is going to make a difference, that having a cake in the room is going to make it harder for people to finish the math quiz. I don't know, maybe. I do like cake. And so if you have that in the room, are people going to be distracted? That's a theory. And then you go out and do the observations. Now that's different from having a math quiz. This is an absurd example, but having a math quiz in a room with a large variety of different sweets and snacks and things, and saying, finish this quiz, but if you're hungry, go get something. And then you do that with enough people, and then each person maybe some people choose cookies, some people choose a banana or some fruit. And then you kind of do some estimations of who chooses which snack or no snack at all. That would be more inductive. And deductive reasoning would be more, we have this theory that it's this sort of thing, and then we would go out and work on that. Now, when I say this sort of thing, I actually mean some sort of phenomenon that we'll have to operationalize. We'll talk about that now in a bit. But before we get there, I want to talk about abductive reasoning. And so that's reasoning from intuition. Now, we can do this either to extend or modify or generate a theory, or even to select a case for observation. The thing is that we, while we do inductive work or while we do deductive work, we often have to motivate that in some way and have that motivated by our own intuitions. There is a kind of condition of possibility for a lot of scientific work. We might have a hunch. I've once heard a phrase said that the most important phrase in science is not eureka, it's that's interesting. And that's interesting is the sort of has the tenor of abductive reasoning, where we have a set of expectations, and then we want to see what happens when something either meets or doesn't meet those expectations. Now, that's not to say we have a specific theory about this. We might just posit a relationship. We might think, people are going to eat snacks if they're in the room. But that's not necessarily a theory about a specific snack, a specific room, a specific event, and we'll have to, drill into that. So all three forms of these reasoning play a part in scientific discussion. Now, deductive reasoning is privileged in this sense, and that's because it focuses on a specific change or a specific feature, and we tend to build up theories of that feature across contexts. So, while inductive work is really interesting, it can often be left unsatisfying because you're not quite sure. Well, in the case of the snacks in the room, did you buy the right snacks? Did you have enough snacks? Were they fresh enough or whatever? There's always a sense that you can add more, and that more might change a classification. Now, broadly speaking, that would be very relevant in machine learning training type work, where you ask, did we train on the right data? What happens if we train on more data, different data, biased data in another way? You always have kind of that uncertainty there with this sort of work. On the other hand, with deductive type of work, what you're doing is trying to focus in on a specific feature or a specific stimuli, and then you can compare that to another stimuli. Is the effect size different? Is it larger? Is it smaller? Or you can kind of rule out the effect of that stimuli on the outcome. And that sort of specificity of deductive reasoning can be really useful. But on the other hand, it's not always available. The thing is, the context of an experiment, either an experiment online where you vary some usability criteria, or an experiment in person where you put someone in a lab and give them some stimuli or not, and then check their behavior. It's very artificial, and there may be a variety of factors that kind of come together, and those factors can either come together because of the context or because of the person in the context. Maybe there's certain kinds of people with certain sensitivities or neurodivergences who are really susceptible to something, but if you don't have them in your experiment, you don't necessarily get to pick that up in the way you do observationally with like thousands or hundreds of thousands of data points. So deductive work, while really useful, can also limit our imagination and limit us to a kind of a sense, by analogy here, if all you have is a hammer, then everything looks like a nail. And so in that sense, what we don't want to do is just sort of impose a particular form of reasoning. What we want to do is understand the uses and limits of all of these forms of reasoning to help us advance the state of knowledge. So now, is abduction simply the most probable? Now, we don't really hear a lot about abduction, but I have heard some people talk about it as reasoning to the most likely explanation, and it's not quite accurate. It was not accurate when C.S. Peirce first introduced a notion of abductive reasoning as a part of the basis of pragmatism, that sort of school of philosophical thought. And it hasn't been more accurate more recently, but some people still use it. So it's worth clarifying that. Now, it can be the most likely explanation, but it's the most likely explanation for the observer based on their expectations. And so that says there's an observer has an experience, they have a sense of habit. And when we see the world, we want to make sense of that world, and we normally try to integrate that into a sense of habit, or a sense of just like, we should just expect this. So this is a sense-making process, and it's often described as intuition, where we kind of know, and cars are going to drive, they're not going to stop if you just walk into the road, but if you keep walking, they might slam on the brakes and honk the horn or whatever. We just kind of have a sense of like, not to do that. Some people talk about this in terms of norms or social norms, but it's not necessarily a norm, because a norm can be prescriptive, no elbows on the table, when really lots of people would violate that norm. So I think intuition still works better. So it doesn't have to be the most probable explanation. You may have an intuition that may be a bit unexpected or fringe, but can really work and can work for you. It has to make sense according to the explainer. You have to make sense of this. Now, the notion of abduction as sense-making is both constraining and liberating. It's good and bad. It's good. It's liberating because it means that we can integrate our biases and our experiences into the generation of research questions and the interpretations of data. You'll notice you don't hear from me in this, probably anywhere in the book, talking about something as being objective. I don't really like that word. I don't think it's very effective. It normally tries to refer to some sort of external validity that you can't even know if it's there. You just say, well, it's objective, and so it is what it is. But I don't think that's going to get us very far, because the more objective something is, also the more fixed it is, and so thus the more fragile it can be. You can get very, very fragile but very detailed data that doesn't really tell us something, in the same way that very nuanced and complicated but hard to get data might tell us a whole lot. Abduction, being liberating, allows us to say, we have these intuitions. I've seen this in the world. You may not have measured it, but it kind of feels like it's a thing. And that could be a positive thing, or it could be a negative thing. Often it's a negative thing, where a sense of, one might have a sense of slights or microaggressions or denials, which on the face of it, someone might say, oh, that's no big deal. But when measured and accumulated, it can be, you can really get a sense of either where certain people might be routinely or systematically excluded from something. If you're not one of those people, you might not even notice it to come up with the research question. Now, that doesn't mean that if you come up with the research question, you necessarily have to prove it. Remember, we're not proving, we're failing to disprove. But it means that we can use parts of our experience in order to guide that process. But once we're in that process, that's where abduction is a bit limiting, because we don't tend to advance scientific claims from intuition. We advance them from either deductive reasoning or inductive reasoning. So we would take an abductive sentiment, a shared experience, and then try to integrate that into our own work. Now, the thing is that other people don't see the world in the way we do. Some do, some don't, in some different ways, and we can accommodate that. But the thing is, so what we want to do then is we want to arbitrate our abductive intuitions with approaches that draw on measurements from the world. We want to say, well, how much of this really is out there? How much of this is my experience versus our experience versus everyone's experience? Being able to do that, we both get to motivate our research questions, but then also try to make our claims as reliable and as valid as possible. Now, one criticism that's often been leveled at data science and or computational social science type stuff is that it's very descriptive. And I think part of what I'm trying to do here is set up a world where we don't make our work descriptive, where we make our work enlightening in some way. So imagine we have a network map. Here's a class. I've seen a lot of these over over the course of the pandemic, a network map of people who tweet vaccine information or misinformation. And so you see these blobs, it looks like splats or abstract paintings. And one cluster over here is going to be the people who maybe quote the misinformation, and there'll be a cluster of doctors and health people tweeting each other, and maybe some celebrities with their tips one way or the other. And then we'll look, and lo and behold, the group that are spreading vaccine misinformation are not really talking to the other group over there, something to that nature. And people will go, oh yeah, lots of science, not really much of a surprise. And so it sounds pretty descriptive. Well, should we have expected that? Should we have just said, well, we kind of assume that the people who are spreading misinformation are not kind of in amongst the others. They're not mixing that up with, pro CDC, pro NHS discourse. Should we have expected that? And if we did, then the work is no longer descriptive. The thing is that we don't have to expect something and then be surprised by the answer. We can confirm an answer as well as disconfirm it. But the reality is, by doing that in either direction, we're then going to have something that allows us to arbitrate expectations and observations. So now a considerable part of scientific research is reasoning by analogy. And so we start with some system, feature, or behavior that has some analogy to past observations. We don't need to go through, certainly, another pandemic in order to get a sense that there's going to be some hostile in-groups and some hostile out-groups who are, some hostile groups that are going to treat others as in and out groups and just not talk to them. That we can see this with all sorts of information, whether it's health information from a previous issue, such as HIV and how people may spread misinformation about HIV, or maybe it's another issue that's not even health related, but still has an analogy in the sense that there is someone with expertise that can talk about it, and someone who might not have that expertise and feel threatened by that information, or may have legitimate reasons to mistrust that information. So having those expectations can set up an analysis, so we're not simply looking at a map and saying it's here and it's there. We can say it's here and it's there, and you know what, we should have expected that. Or it's here and it's there, and we didn't expect that, or we didn't expect so much connectivity between them, or we didn't expect it to one side to be really concentrated in one way, with maybe one charismatic figure does all the talking, and the other side to have lots of people talking. As soon as you start making these sorts of differences or comparisons, you elevate your work away from just description. I'm going to go out and get some data. Let's have a look, and then making it more scientific in terms of negotiating expectations and observations. And you haven't really done a different research design. You've only framed it in a different way. So if we're going to go out and compare what we observe to what we expect, there's a couple different approaches to that, and some of the main ones, key ones here, is thinking about it in terms of prediction or explanation. Now they're related, and they both have a form of statistical reasoning along with them. But they are different enough that it's worth considering them, and considering them as approaches that you can integrate. So we use prediction to characterize or model a system. Now the model should make a guess that explains variation. So what we want to do when we want to predict something is that we will have some model, and then we will go out and say, give me an observation. This is I think that I don't know, the price of a toothbrush should be £1.50 or maybe $2 or something. And so then I can go out and I look and see, is that going to be a good prediction? And we might say, wow, you seem to really know the price of toothbrushes. And I go, thanks. I've been, looking at the price of toothbrushes all day, or something absurd like that. Or I've been shopping for toothbrushes for a while. And what's happened is that you're not necessarily thinking of what is going to make a toothbrush more or less expensive? You're thinking, how can we make the best guess about the price of a toothbrush? So, but it's, obviously it's not just about toothbrushes. It's about, you have some sort of outcome, and you want to make the best guess of it. And it doesn't really. It's less important which factor helps the most in making the best guess, but more about, can we make the best guess? And so if you throw lots of stuff in the model, that's okay, if that increases our understanding, our ability to predict. Now, our ability to predict isn't our ability to forecast. It's not our ability to see something out of sample. It's our ability to effectively characterize a distribution. So it's not about then, how do we predict the price of avocados from a toothbrush. It's, how do we, we have data on toothbrushes and so forth, and we just want to predict the price of this one in this place over here, and then see how our model does. Now, we might think then that more data is always good. And it is the case that more data is usually good and sometimes useful, but it's not that more data is always good, and a more accurate prediction model isn't always the best goal of research, even if the goal of doing better prediction is to explain more variation. And the reason is because being able to predict more within sample can sometimes lead you to overtrain a model, to overspecify a model, to be too specific. And sometimes a better prediction in a qualitative sense, if not a quantitative one, might be a prediction that makes a model that makes fewer assumptions. You may have one model that makes assumptions about your data. It needs to be normally distributed or whatever. And another model that says it doesn't matter if it's normally distributed. It can be rank order. You can have stuff that's really skewed and it still works just as good. And so that might be one way to say qualitatively, well, this could be a better prediction because it's more parsimonious in that regard. It might require, what about something that requires less computational power? There are some models that are really, really good, but they're very computationally expensive. So if you have to repeat them over and over again, you might get to a point where you just simply can't. You don't have enough number, you don't have enough data, and so you don't have enough time. Being able to do something quicker and it get just around the same amount of prediction can also be a good thing. And another is, of course, can it be better generalized out of sample? So you can predict something really, really accurately within sample just by having a model as long as, or almost as long as the amount of data you have. And so the problem with that is that it's definitely too specific. It's like a map that shows all of the territory, and it's so big it's basically the size of the territory. We don't want that. We want to be able to generalize out of sample. And so if we, if it's about toothbrushes, we might want to think about toothbrushes next week. We might want to think about shopping for one when we're traveling. And so we don't necessarily just want to have a model that's the most accurate. We want one that helps us build up knowledge, and that's knowledge both about situating something in its context and thinking about multiple contexts, which we can also think of as out of sample. Now, in contrast to prediction, with explanation, we're not really so concerned with making a model that explains the most variation. There could be other factors involved that we didn't measure, that we don't even know. But we suspect they might explain variation, but that's not our goal. Our goal is to understand any particular feature, we call a variable, normally something that measures a phenomenon, whether that has a contribution, whether that makes a contribution to some other distribution. So if we think that our toothbrushes are having toothbrushes that are I guess the bristles are soft or medium or hard, does that make a difference to the price of a toothbrush? And so we imagine I once bought a toothbrush at some store and it had nice soft bristles. No, isn't this wonderful? But it was really expensive. So then I start thinking that the price of toothbrushes really varies by whether the bristles are hard or soft. Now, I suspect actually it doesn't. So what we can do then is create a model. And then that model is going to, we put the price of toothbrushes in there. and that's going to be our response variable. And then we put the price of, we put the type of bristles of the toothbrush in there, and that's going to be an explanatory variable. We're going to use that to explain our response. And depending on the statistical approach we use, we might get some sort of measure or metric, could be a p-value, could be some other score, that will give us a sense of the relative contribution of the feature, in this case the color of the toothbrush, on the outcome, in this case the price of the toothbrush. Now, a model that explains better is a model, in this case, it's not one that explains more variation. It's one that is more certain of the relationship between any variable and another variable. So it's less like we can guess the price of a toothbrush in every different store, and more, it's like we really know that that the thickness of the bristles make a difference. We were really certain of that. And then someone might go, all right, well, did you take into account that some brands, which are more posh or more expensive, they're the only ones with soft bristles or the only ones with hard bristles? And so that might be a possible mutual explanation. It might be you might have a spurious relationship. It's like, oh yeah, I remember I bought that luxury toothbrush at the store, and so that's why it had the soft bristles and whatever. So in that sense, with the explanation, we are no longer entirely certain of that explanation. Now, we're never absolutely certain. Remember, because what we do is we only fail to disprove something. But we want to be more certain rather than less certain of a relationship. Now, we also want to consider that certainty in terms of, does the variable mean the same thing across contexts? Now, surely the price of a toothbrush, not the most complicated thing, but we will want to use models that talk about things which can vary significantly. So this kind of gets us together to a place where we can think of inductive predictions and deductive explanations. We talked about inductive and deductive reasoning, but now we can think that some kind of research questions can lend themselves to specific kinds of approaches. Some can be more inductive, some can be more deductive. Let's take linear regression, for example. Now, some might think of linear regression as just totally a great technique for explanation. We have a series of what we call independent variables, or explanatory variables, and we have a response variable or a dependent variable. We try not to use the terms independent and dependent anymore because it kind of shoehorns in a little implied causality in there, but it's not causality. It's that we have one measurement and that we want to see what other measurements can most effectively help us predict that measurement. But which one caused which one is a much more complicated issue that would require specific research design, but we can still just use one measurement to predict another. So explanatory and response can often be more effective. So we have a regression. It's a line of best fit, they'd say. Now, how can we consider it as an inductive technique? Normally we think that, well, if one of the variables helps in the regression, we might say it's significant, then sure enough, we're going to say that that it helps, so it explains some variation. But, well, imagine we're not sure which variables matter. We can think of things like stepwise regression that kind of adds in a variable if it's significant or takes a variable away if it isn't, and iterates through a bunch of variables to get a model that it thinks is the most parsimonious, that it's the most explains the most variation in the simplest way. We can also think of a lasso approach, or lasso regression, which is kind of like a stepwise regression, but it doesn't just like add a variable in and take one out, but it does try to find the best variables of a very large set of variables that can be used to help explain a model. So the thing is that while the actual approach itself seems very lends itself towards explanation for the specific variables, you can actually think of it in terms of prediction for the whole ensemble or for the whole model. So we think that, well, if we use these variables, the model will have a better fit. Or if we don't use these variables, the model will have a better fit. And so then that can become inductive. But as a deductive technique, it's almost pretty straightforward. We examine the significance of any model in a regression. We say, oh, this really contributes to that model. Now we can compare models deliberately also by adding control variables or doing other approaches like a nested regression. We first set up a model, hey, it's significant, and then we say, and now we're going to add some psychometric scores. We're going to add some personality variables. Do the original things are they still related, or are they not related? And so in that sense, of course, as a deductive technique, we're theoretically trying to test the presence or absence of any given feature or any given variable, and use that in order to help us say that's probably why these two are related. So now classification, on the other hand, people would normally think of that as a very inductive technique. When we classify something, we often will optimize according to model fit. The best classification of a system is often the one that we might say is maximizes differences between the different sets or groups in the classification and minimizes differences within the classification. Let's say you have a whole series of records, and when you classify, what you're trying to do then would just say, how can I put these in genres so that we know, if I think of a genre, I know which one to go to right there. It's not a matter of explaining which instruments go to which genres, but just simply saying, how can I make this the most distinctive? Now that's not always the best approach, but it can work, and it often does. So for example, we might tag some speech as hate speech and then find a model that best detects it among other speech. So now in inductive classification, seeking to maximize differences between the sets, topic modeling is a classic example. So that's a technique often called LDA, or latent Dirichlet allocation, and it tries to classify a set of documents according to the words in those documents, and you would set the number of different groups, and it just tries to find the groups that are the most distinctive, and then it'll tell you which words in those different groups really made the difference, really made this group stand out as one group. So maybe it's a bunch of tweets, and these all talk about politics, and these all talk about entertainment. And so it's called topic modeling, and it's very inductive. The reason it's inductive is not because it's a classification, it's because the reasoning we use about it. We see the classification, we see that there's a bunch of different groups, and then we go, oh, here's the keywords for this group, and it's probably about politics. That's the inductive reasoning. We see this, and they're talking about celebrities and some movies and whatever. That's the entertainment category. That's the inductive reasoning. We're getting those observations and then making theory by bounding it together as a group. And what about a deductive approach to classification? That doesn't really seem like it would necessarily work, but we can certainly do it. It happens when we start to compare classifications. So we have a classification, but then we add new data. So we might say by adding tweets from 5 years ago, our classifications change because the notions of maybe entertainment and politics have changed. Maybe what used to be considered politics is now considered entertainment, or vice versa. You can think of different sampling strategies. Imagine you have millions of tweets, and you can't really put them all into a model at the same time. So you think of, if we sample on this versus we sample on that, can we classify better? If we sample on, say, political tweets, can we find more polarization than if we sample on recipes or food blog tweets? We can evaluate different approaches. If we classify using this approach, maybe something based on logistic regression versus something based on an SVM, support vector machine. They're different approaches. And so we might have a hypothesis that says for some reason, or for a specific reason, one would work better than the other. And if it does, then that, it can help guide us. So by motivating our choice of comparison, we're using deductive reasoning. We're having a theory about what difference was there and how that can, explain some variation. So now we do this selecting a classification technique or doing feature selection. And, I say feature selection because we don't just put words into a text classification. We might put words and some grammar about them, or if we're looking at faces, we might label or tag those faces before classifying them in some way. Those tags or those labels are themselves already, they're deductive. We have a theory about this work and we apply it to our observations rather than do observations and then make a theory. I want to talk a little bit about resampling because it's pretty common within data science work and not so common within social science work, although those things of course are blurring and changing. The idea behind resampling is that we don't need to use all of the data all the time. Some of that is sampling within the data, and some of that is sampling within the data repeatedly. So this repeated sampling would be resampling. Now we might want to do that in order to make a computation more tractable. We might want to attenuate the influence of an outlier. When we resample or continuously sample within, any given outlier may or may not show up in that particular sample, so its effect on the overall estimation can be a bit muted, which is good. And we can also do it to understand how some variable can influence model fit. We don't need to randomly select from a sample. We might bias our selection in some way. We might say, if we sample on time, so that we take things that are on Mondays instead of Sundays, is that going to make our classification any more effective? I mean, it's a bit facetious, I suppose, but the idea is that we don't simply need to work within the classification. We can bias our sample and then say that makes a difference. So now the way we can actually do the sampling itself, taking some observations from a larger pool, that can vary. So we can use all of the data. Now we can do that, but we risk overtraining. Now we can randomly sample within the data, and we can do that repeatedly to attenuate outliers. We can make a bias sample based on some feature, kind of like what I suggested up there, and we can do that to compare model fit. If we sample biased in this way, we sample only on, for example, on tweets, on political tweets. If we bias our sample so the tweets that get more likes are more likely to show up in our sample, is that going to make a difference? I mean, maybe it should make a difference because those tweets are out there, and so the ones that were very viral or very popular probably have something going on that the ones that are less popular don't have going on. No, not always. Of course, some people just have really witty things to say, and no one's following them, no one's listening. But again, that's within the distributional level. We might posit some explanation, and so we can do that, bias our sample that way, and say, wow. It looks like it's easier to classify political tweets when we sample on popularity. Now, of course, the last way to do resampling is really common within the training of models or the generation of a model to explain a system. We don't model all of the data usually. Instead, we split our data into 2 or 3 groups. If setting into 2 groups is a training set and a test set. So a training set, such as in a naive Bayes classification, or certainly more complicated models than that. In the training set, it calculates the words that are co-associated. So the same words in this document, or the same words in that document, or might be the same in the set that we label left wing. We see lots of content that we don't see in stuff labeled right wing. So we see that in our training set, and then we say, okay, so we have a model now. We think if it says freedom, it's right wing, and I don't know, if it says diversity, it's left wing, or something like that. And so if you do that and you find that in your training data, then you say, well, is that really the case? You go out and you apply that in the test data. And if it similarly classifies the test data, then we say, okay, maybe our classification works really well. If it doesn't similarly make a difference in the test data, maybe the test data, the left wing, they're not talking about diversity, or they don't say that word, or but maybe they talk about taxation. And so you just happen to have randomly sampled your training data in some slightly biased way, and it'll be a bit revealed when you go out and apply it on your test set. So often you can iterate through this so that you have different training and test sets, or you shuffle them around. So this time we train on this and then test on that, and then we train on a little bit of a difference and test, et cetera, et cetera, et cetera. You keep doing that iteratively. Eventually, you may find a model that says, okay, now this is the model that we think is the most effective at explaining the difference between left and right, or pro environment or not, or whatever. And then you go to your holdout set and say, okay, and now we'll test it on our holdout set and see how it worked. And so that third set is often very useful because while you're not really training on your test set at any time, over time that test set and that training set, because you're ping-ponging back and forth, you really want to have a set that just is not influencing that model that you then go and estimate with. Okay, so one of our last topics here is operationalization, and it's a really important topic. I've mentioned it already. We've said operationalization is how we translate phenomena into measurements, and so of course it's worth mentioning here in respect to research questions. So now research questions can sometimes they can really deploy a phenomenon but resist a reliable measurement. Now I say deploy a phenomenon, and why do I say that? Well, I don't want to say describe, because in that sense, the better we describe it, the more it can probably be measured. But we can allude to, we can connote, we can imply, we can suggest things, but still people can get it. So there's a related concept in German, and again, not very good in pronouncing it, but Fremdschämen. And this is not taking pleasure in the misery of others, but kind of that sort of cringe or wince sense of feeling secondhand embarrassment, like, oh gosh, I can't believe they did that. All right, so you can describe that in a way. You can kind of deploy that. I just deployed it. I went, oh, and I did that little impression there. You can give someone a sense of that, and they go, oh, I know. I've been there. I've seen that happen. Now, lately, we might call this cringe. I've cringed at somebody else's content. But how do you operationalize that? How do you describe that in such a way that we can reliably measure what's cringy? Is what's cringy, does it stay the same over time? Now, it might be a bit tricky. But if we can't do that, then it's difficult for us to be able to know something about it. Now, we don't have to fully define cringe in order to operationalize it. We might say cringe is whatever we see on a social media site dedicated to cringy videos, and then we kind of work our way back from there. So the thing is, we can consider some phenomena out there to be unique and subjective. What I cringe at and what you cringe at might be different, but they help us reason abductively. I think. Well, I cringe at things where people interrupt a meeting with something about themselves, and so that happened to me once, and I went like, oh, you shouldn't have done that. And so that's abductive. That's this intuition. I have this experience, and then I might be able to define it in some way, as in how much of cringe is about people interrupting things, and that's an operationalize it. So we operationalize a phenomenon by describing a measurement that we believe reflects or otherwise correlates with the phenomenon. We don't necessarily have to describe all cringy things, and we don't have to necessarily say that all events are cringy, but they do relate when we see one with the other. So now it's worth noting there's a difference in this sort of relationship between a phenomenon and a measurement, that sometimes we're talking about it as with respect to its reliability, and sometimes with respect to its validity. A reliable measurement is a measurement that uses a consistent medium or instrument, and that the responses are also consistent. So that when we ask a question, if we were to ask it to the same person repeatedly, and we get the same response, we might say it's reliable. Or if we have a measurement of somebody's behavior, maybe they're clicking around online, and it always shows what sites they go to, but doesn't show like cookies or trackers or pop-ups or whatever, maybe we'll say that's reliable. But now, to say a measurement is reliable is not the same thing to say it's valid. Reliable is that it's consistent. But we could be consistently wrong, is the problem. We could be very effectively measuring something, and so our measure is very stable. If we go back and measure it tomorrow, we'll get the same value, but it might not actually relate to the phenomenon. And so a valid measurement is one that minimizes the distance between the phenomena we seek to understand and the measurement we use. We might not be able to ever fully close that gap. Cringe might be just an abstract concept, but we want to close that distance there. And the more we close that distance, the more we can say that our measurements are valid, so that what we are talking about what we want to talk about when we present people with observations. So here's an example, operationalizing the friendship. There is talk that people are now more lonely than they've been in past eras. That's not a great sense, not a great realization. But on the other hand, people have access to more information and more potential people than ever. So in theory, surely people shouldn't be more lonely if they have more people to talk to. But in this context, how could we operationalize a friendship? Well, we could say we could do it with trace data, with behavioral data, with survey data, with interview data as examples. Now imagine with trace data here. We might come to the wrong conclusion if we say, well, people have lots of followers on Twitter, or people at mentioning them, they must not feel lonely. Or with behavioral data, similarly, we might go out and see people. Well, do they talk to a lot of others? Do they approach them? Do they be approached by them? It might not be the best way to operationalize loneliness or friendship, but it might be an effective way. Similarly, with survey data, we can ask, how many friends do you have? And with that, we might get an accurate measure, or we might get an overinflation. We know that historically, unfortunately, that certain kinds of questions have been asked that people will inflate the answers to them, or reduce the answers and have some sort of social desirability bias. So with survey data, we may have to disentangle that. And with operationalizing, with interviewing someone about their friendship, it could be very much in depth, but we may get into a person's own notion of a friendship, which may actually vary from other people's notions of friendships, and so we can't necessarily make consistent measurements. None of these ways are perfect then, well, because none of them are really a friendship. None of them are really a subjective feeling, but they will get at different dimensions of a friendship, and depending on what you want to understand, whether you want to classify friendships or explain whether some factor makes a friendship more friendly or more enduring, you might use different approaches to each of these. So now recall that we can use both inductive and deductive reasoning. We might want to find an approach that best predicts the likelihood of a friendship between two people. If you're running an online dating company, that might be very important. Or certainly on social media sites, if you have to recommend people to be friends, you want to get a sense of what's likely going to be the best recommendation for people. On the other hand, you might be trying to identify the presence or absence of specific factors which might explain a friendship. Do people live nearby? Can they meet in person? Do they have friends in common? You can put both of those in a model, but they have a different focus, and so thus the research question itself will have a different focus with that. You might think, does timescale matter? Actually, with respect to timescale, I wanted to for my last point, just really raise this one specifically in terms of boundedness. While we get lots of data, everything is bounded in some way or another. Some things might only make sense in certain eras, certain time periods, only among certain populations or certain cultures. It could be under certain socio-technical assemblages. Now, a socio-technical assemblage is a kind of a long word, or a long phrase, but it really means that a set of people and technologies that have together. I don't have any internet. I'm not going to be on social media. So We can be a bit more granular than that. I have the internet, but I don't have VR. I'm not going to go into VR. So that could be it. But it's not just the technology in that sense. But if you want to know a little more about that stuff, maybe checking out some STS studies for some theories there. And of course, cultures as well. Even within the same population, there can be cultures and subcultures of people who would understand the world slightly differently. So consider time as one example of boundedness. Imagine we make the claim teens love Facebook, which is not so true anymore. So if we find that relationship, imagine it's 2010, and we're looking at who is on Facebook, and we find that a lot of teenagers are on Facebook. It's really cool. It was just opened up to the public 2 years prior to that, or 3 years prior to that, thereabouts. And so before then, it was only college students. A lot of teenagers started adding, each other on Facebook. Okay, are they still on Facebook? Do they still love it? Are the same teenagers there? Well, we can structure this in terms of boundedness and think about coverage in terms of age, period, and cohort. So an age effect is, we might say, well, when people are teenagers, they enjoy Facebook. Now, we don't necessarily believe that that's the case anymore. I think teenagers these days are more likely on TikTok. So we wouldn't necessarily make a claim that it's an age effect in the same way that we would say when people are teenagers, they're rebellious. In many cultures, teenagers are rebellious across time periods, but they might not be rebellious on Facebook. Now, there could be a period effect. In 2010, people were especially joining Facebook. Now, I do think that's the case. I mean, the movie The Social Network had just recently, I think, come out or won an Oscar. It was kind of the talk, if you will, back then. There was a buzz around Facebook. So people broadly were quite interested in Facebook. But of those people, teenagers were particularly keen on Facebook. So there might have been an age and a period effect happening at the same time. Now that might be different than a cohort effect. Now the cohort effect might also be real. So the people who were in their teens in the 2010s would be in their 20s now. So maybe they liked Facebook back then and they still like Facebook even if the teens today aren't into it and they go into TikTok or Instagram or something. So the cohort effect would be that particular group of people itself moving through time, but they are all kind of stick with that relationship. A period effect would be as time happens and you get this sort of like the buzz for everybody at the time, and an age effect would be as people themselves age, they become more or less interested in certain things. So all of these are ways in which you need to bound your research question. You may have a question that because you only have a certain age range or a certain window of time, you can't necessarily be confident in that the relationship teens love Facebook is going to endure. So you don't necessarily get to think about all the ways in which your work is bounded. Some might emerge over time or emerge only as you think about how your work compares to others. But you should be able to have some intuitions of it. Another one, for example, is geography. So are we sampling from a known geographic boundary? That's a little more obvious in survey research, so you would say in the UK. But if you're doing work online, if you're going to pretty much any platform, Twitch, Discord, TikTok, they don't really abide by national boundaries, even if there are cultures that are correlated with nation states. And we also thus think about the platforms themselves as being spatially clustered. So I say consider Bebo versus Hives. And Bebo and Hives haven't been relevant in over 15 years. There was a time in the aughts when there was a lot of nationally popular social media sites. So in America, it would be MySpace and Facebook. But Bebo actually was, for a time, the most popular social media site in Britain, and Hives was the most popular in the Netherlands. And so if we have a lot of data on Hives and how people connected there, are we saying something about how people connect on social media, or are we saying something about Dutch people? Similarly with Bebo, are we then saying something about how people use an online blog platform? Are we saying something about how British people use an online blog platform? In the end, these kind of fell aside to some more popular and generally transnational social media, but the data still exists there. And for any one of our sites, or any site that you may consider now, you'll still have that case, whether you're looking at work on Wikipedia, which would be biased by more people within the West, the global North, doing more editing than people in the global South, or if you're going on Twitter, TikTok, etc., where you may get an overrepresentation of some cultures and an underrepresentation of some others. So now we often want to make out-of-sample claims, and so therefore we need to understand how these claims are biased by the boundedness of our sample. It doesn't mean that our claims are necessarily doomed, just that they're a bit limited. So to summarize for today, research questions are focusing devices, and we want to use that to focus in on our research. And then as we're focusing, we want to use reasoning to determine how to make claims from observations. We focus on stuff, we think about the observations to get, and then we make claims about it. Our intuitions and some past literature can help us to set up some expectations. We don't want to come at work cold necessarily. Even if we're doing something as inductive as grounded theory, we're still selecting the context. We're still looking at which people to interview. We're always involving some intuitions somewhere. But once we have those intuitions and that set up our expectations, then we want to get some observations. And observations are not a place where we necessarily want to magnify our intuitions. It's places where we want to do work that's reliable and work that's valid. But just going out and getting the data is insufficient in a way. We could do that. You could say, here's some relationship. This is correlated with that. And it can still end up being really descriptive. It'll just say you're just restating or summarizing what's there. In order to elevate that work, not only do we want to use a research question to focus in, we also want to think about how we've developed that research question as having a set of expectations. And so when we have those expectations, we can use those expectations in order to motivate our analysis and help us interpret what's there. Then even work can just be stating some things isn't necessarily descriptive, because we can state those things in comparison or in contrast to that which we would expect in this context or in this space. Now, our goals for analysis can vary. Sometimes we want to explain something, and by explain, I mean we want to identify a particular factor and have some certainty about whether that factor influences something else. Now, the influence process, in this sense, I'm going to leave ambiguous, so we might say it's related to something else. We could also say that causes something else, but that's a much more stringent setup. On the other hand, we might not be interested in which specific factor causes, influences, or predicts something else, but just how we can take some outcome and do the best job of predicting it, predict the most variation of that thing. And so in that sense, we can look at things as predicting, just get the highest R-squared score, for example, have the lowest mean squared error, and so forth. And in that sense, we can think of our tasks as having both prediction and explanation qualities. Now, of course, our observations are inevitably bounded and biased. We should consider that bias, see how we can use that bias to limit our claims. That's not a bad thing. It's making our claims more specific. That helps us understand, not just the limits of our claims, but the limits of our analogies as well. As stated earlier, we use analogy in order to say we don't have to just look exactly at the same research that other people have done in order to do our own. We reason by analogy to think that there's some similar research. But the ways in which it's similar and the ways in which it's different are often about both how we operationalize the data, how we take a phenomenon and measure it, maybe measure it differently, and how the context in which we observe those measurements itself is limited in some way. But then once we integrate that into our work, that can help us then advance our paper, say this is really interesting, and someone else may say, oh, I'm going to try that in a different context, or I'll replicate that, or I see I see something in my work that's similar to something in yours, and then we kind of get a much more, hopefully, a much more effective, clearer, or more elevated sense of knowledge about the world as a context or as a consequence. So now, a bit of a dry lecture, not much coding. But still, it's a good lecture, I hope, for thinking through some ideas now that we have this data and what we do with it. So, I want us to test those ideas in a way. So, with a topic that you enjoy researching, find a scientific article that makes a research claim. So, it could be anything. There's a lot of different ways in which we can apply social data science. Surely you've read other papers and other work of your own. Go back and have a read again. A paper you like. See if you can identify the research question within that paper. Was it obvious? Did they say at the end of the literature review, this leads to the research question 1, and here's our research question? Or do you think they have a more implied or implicit research question? Surely every paper published in a decent journal is going to have some way of focusing in the argument, but do they state it in one line or not? Now, there's examples in the back of the book, or in the back of the book chapter on research questions, where I quote different academics' work and how their research questions vary in specificity. You can check that out there, or just keep looking at a number of papers until you find one that either really states the research question or doesn't. And now here's a more applied example. Consider the topic of hate speech. I mean, if you must. For this, hate speech is it's not great, and it's not something I think that leads to a very healthy set of communication practices, but it is something that seems to keep appearing on the internet. So there's clearly a will to moderate content online. That's just it. Now, is that will well-founded or not? It's a rights-based question. I'm going to argue that it's in many cases is well-founded, and that people have a right to not feel attacked or hostile in their place in some social media space if they want to define rules to say that this is appropriate. Okay, so let's just imagine that people have a sense that some things are inappropriate on a certain platform. How could we set up a deductive argument about that? What would a deductive argument be? How could we set up an inductive argument about hate speech? Would we need to use supervised learning? Would we need to tag some speech as hate speech and not speech? Is there some other ways in which we might be able to detect hate speech inductively? Would hate speech depend on the speaker? Are there some places where certain speakers and audiences would consider dialogue not to be hate speech? So use abductive reasoning to think of ways in which some speech is highly context dependent. And then think, well, okay, maybe you have an intuition of some. Can we measure those contexts? Can we think of how bounded those contexts are? Now, this is not to say go out and do this work, but try to think of the different ways in which you could indeed maybe set up a deductive theory that something is or isn't hate speech, or someone will or won't say it. And then an inductive argument about, can we classify it? Can we predict effectively whether something is or isn't hate speech, or where it could appear? And then indeed, your intuitions for some of the limits of that. So I'll leave those questions for you to have a think about, and then I guess in the next chapter we're gonna move on to back to data, back to code. We're gonna start looking at visualizations and maybe a little bit of stats. Hopefully this stuff will be kind of less abstract when we start looking at the code. But I do thank you for your time and for your attention for this.